All right, so as you can see here, I attempted the algebra and I looked at the book to see if I was on track, and the book doesn't even expect you to do this kind of algebra. They just expect you to be able to set it up, and then they use some sort of a matrix solver to solve the system of equations. I am not doing that. I don't expect you to do that, and I also am not going to expect you to solve problems that are this, algebraically intensive. So I am going to stop because I decided it was not a good use of our time for me to just do a bunch of algebra. I came over here, I solved for I1 in terms of I2 and M. I plugged that back into expression 1, and I decided just not to finish this problem because I don't think that it's really worthwhile. The most complicated circuit I'm going to ask you to solve is something that looks like this, just basic 2 coils. I'm not going to ask you to do anything crazy. This is a unique topic, and it does get really rigorous in terms of the math pretty fast. So even just a circuit this simple, you can see that it's starting to get really ugly, especially because they gave us 3 known values of M, and I'm trying to solve it in terms of M. If we were to just take one of these, specifically if we were to take M equals 0, all the terms with the M's would just go to 0, and it would be really easy to solve. And you could go from here and just solve it if you want to, and just plug in values of M into my 2 expressions here that I derived. And it would be pretty easy to solve, pretty straightforward. But the point of this class is not to just chomp through algebra. The point is to understand the concept. So if you understand how we got from here to here with the dot convention, I think that that's good enough, and you don't need to worry too much more about this problem. So I'm going to go ahead and end this video. Just wanted to make that clear that I'm not going to spend all this time trying to wrap up this algebra. I'm just going to call it here. Yeah, I'm sorry if that's unsatisfying, but it's just not a good use of our time. And so in the next video, I'm going to solve a much simpler example where we basically take a couple of inductances, use the dot convention and the mutual inductance, and determine what the equivalent inductance is of the 2 coils with the mutual inductance. Okay, so I'll end this video here, and in the next video, we'll work on this example problem.